Hey everyone, I'm back with another problem on the InterviewBit series for the topic arrays. So the problem is called Maximum Sum Triplet. Let's read the problem statement first. So we are given an array containing n integers and we need to find the maximum sum of triplet a of I plus a of j plus a of k such that I less than j less than k less than n. Right, so the indices should be in increasing order and a of I is less than a of j and is less than a of k. So the indices should be in ascending order. Also the numbers which we have chosen should be in ascending order. So there are two conditions that we need to satisfy here. Okay. Also if there is no such triplet, you need to return a 0. Great. So let's look at this test case here. Right. So the first thing, the first brute force solution which comes to my mind is I'll try for all the possible triplets here, right? I'll try for all the possible triplets here. So I'll need 3 for loops for that. So in that case, the time complexity is going to be O of n cube. So this is the brute force approach where we try all the possible triplets and take the maximum sum out of everything, right? Can we improve it? Can we improve this O of n cube? I think we can. So how do we do that? Okay, let's say we fix an index I. Okay, we fix an index I, we loop for I for 0 to n and we fix it. Okay, now let's have another index j and we'll iterate from j is equals to j is equals to 0 to I minus 1. Okay, let's have another index k and we'll iterate from I plus 1 to n. Okay, so in here in this condition we'll check that a of I should be less than a of j, and in this condition we'll check that a of k should be greater than a of I. Okay, so we are using two for loops here, right? So we have basically optimized this O of n cube to O of n square, right? We can fix an element, we'll iterate from 0 to that index and from that index plus 1 to nth index, and we'll try all the triplets here. Okay, and we'll take the maximum one. So we have reduced its complexity from O of n cube, which was brute force, to O of n square. But the main question is, can we optimize it a bit further? As you look at the problem constraints, we have n is less than or equal to 10 to the power 5. So we need a better solution for this, right? So let's work on towards that. Okay, so the idea is, at any index, what are the conditions needed to be satisfied? I should be less than j, should be less than k, and a of I should be less than a of j, and this should be less than a of k, right? So let's assume I fix an index. Okay, so if I can get the maximum value, like if I can get the maximum value such that it is less than my current value, which is a of I, we need to maximize a of I, but it should also follow this condition that a of I should be less than a of j. This is the first part which we need on the left hand side. What is the right hand side condition? Right hand side condition says that j should be less than k, which is obvious. If you fix this element and if you move in the right of this current element, so all the indices would be greater, which is obvious. So you need the maximum element from in the right side. Okay, so how will you get that? How will you get that in a, let's say, constant time? So what we can use here is, just to get the maximum element for a current index towards its right, so we can use a suffix max array for this, right? And we can look up to any index in constant time. Okay, so for this we can use suffix max array for this, right? Perfect. Okay, but the left hand part still remains unsolved. So what do we do for this? What do we do for this? Okay. Okay. So if we look at the problem more closely, we'll see that if we look on the left, so this is kind of satisfied. This is kind of satisfied. What we need to just do is maintain some sorted order of all the elements on the left of ith index. Maintain some sorted order, and we'll try to find out the maximum one which is just smaller than the current index. Okay, seems like we have heard of this before. Isn't lower bound the same thing? Isn't lower bound the same thing? What is lower bound? So lower bound gives you the maximum value which is greater than or equal to my current element. Okay, which is greater than or equal to my current element, right? So this would give me greater than or equal to my current element. So what, let's say my lower bound is j. So what would j minus 1 give me? J minus 1 would give me the maximum element. J minus 1 would give me the maximum element which is smaller than x, and that's what we need, right? So if we can maintain a sorted order of all the elements to the left of ith index, and so we can apply the lower bound there, and the element just before the lower bound will give us my answer, which would also be the maximum, but it would also be less than the current element, right? Perfect, perfect. So now let's dry run through this test case and see it if this works. Okay. Okay, now let's move on. So for 2, let's maintain a set, but before that let me create a prefix max array. Okay, let me create a prefix max array for this. Okay, so for 9 I do not have any element, so I'll just assign 9 here. For this it's going to be 9, 9, 9 and 9. What is suffix? So this is my suffix max, right? This is my suffix max. What suffix max gives you? Let's say you are at an index I, so it would give you the maximum element to the right of I. Okay, that's what we need for the RHS side. So RHS side is done. Now let's move on to LHS side. For that, I'll maintain a set. Okay, this would be currently empty. Now I'll start iterating. So this is my ith pointer. And if it is 2, so what is the suffix max for 2? It's going to be 9, right? And the set is empty for now. So we do not have any elements on its left. So in this case, it won't give me any answer. So we move forward and we'll put 2 here. Okay. Okay. Now let's move on. Now we have 5. So for 5, what is the suffix max? It is 9. Right. And in the set, we'll check the lower bound of 5. So lower bound of 5 is nothing. Everything is smaller than 5, right? And so lower bound minus 1, which would give me a 2. And that actually satisfies it, right? So I'll also maintain an answer, right? So currently it's going to be 2 plus 5 plus 9, right? Which is uh, 16, right? So my current answer is 16. Perfect. Now let's move forward. We'll put 5 into a set and we'll move forward. Now we have come to 3. So for 3, what is the suffix max? It is 9. And what is the lower bound for 3? It would give me the greater element than 3. Right, so it would be 5. And what is lower bound minus 1? It's going to be 2. So in this case, for 3, my answer is going to be 3 plus 2 plus 9, which is equals to 40. Is 14 greater than 16? No, so we won't update it. Similarly, for 1, it is 9. And what is the lower bound for 1? None, right? We do not have a element which is smaller than 1. So we won't consider it, okay? Right, and we'll put 1 into this set. So now we have 1, 2, 5. also 3. Right. Now here comes 4. So for 4, what is the suffix max? It's 9. So, and what is the lower bound for 4? It's going to be 5. So lower bound minus 1 is 3. So answer would be 4 plus 9 plus 3. It's going to be 16 again, right? Now let's consider for the right. So we do not have any element in the right for 9, so we won't consider it at all, right? So here my maximum answer is 16, right? So what is the time complexity for this solution? For the time complexity, we have iterated the array once, and we also look at every instance in the set for the lower bound. What's the time complexity of calculating the lower bound? It's O of n for into the set, and the total becomes O of n log n. And what is the space complexity? Since we are using an external set here, so it would be O of n, right? So this was a really nice problem, and it's one of my personal favorite problems. So this involves suffix max and a sort of binary search of just calculating lower bound. But the sheer idea of optimizing it from O of n square to O of n log n is quite beautiful, right? Now let's move on to the coding part. Okay, now let's code it up real quick. So we are given an array. The size of the array will be a of size. Great. Now we need to calculate the suffix max for this array, right? So I'll say vector int sf, okay, and the suffix max for the last element is going to be the last element itself, right? Now we can iterate from the second last element. We'll go up till the first I minus minus. Suffix max of I is equal to maximum of suffix max of I plus 1 and current element. Now we have successfully created the suffix max array, right? Now we need to create a set, right? Now we'll iterate from I to n minus 1, I plus plus. Why are we not considering the first and the last element? Because for the first element we do not have anything on its left, right? And for the last element we do not have anything on its right, so we can actually ignore them and only consider the middle ones, right? Also make sure you push the first element into the set, but because this can be part of an answer. Also let's maintain a variable called answer, assign it to 0, right? So for the current index, what would be my suffix max? It's going to be suffix of I plus 1. Now we need to check if the right element is actually greater than a of I or not. If it is, then we have one part of the condition sorted. Now we need to just check the LHS part of the condition. So for that, what I can do is I can calculate the lower bound. So I'll say iterator is equal to set dot lower bound for the current element. So what would lower bound give me? It will give me an element which is either greater than or equal to the current element, but I do not want it. I want an element which is maximum, but it should also be smaller than my current element. So if I shift my lower bound to 1 back, we'll get exactly that, right? So I can say my left element is gonna be just dereference this pointer. Okay, so now we have left, right, so we can update the answer. Answer is equals to maximum of answer, comma, left plus current element plus right. Okay, make sure you also push the current element into the set. Keep pushing it, right? Now we can return the answer. Everything looks good, just submit it. Yeah, so it is accepted. This was a really nice problem. I hope you guys understood the solution. So I'll meet you guys on the next video. Till then, take care. Okay, chalo, bye.